Our focus standard for today's lesson comes from Grade 8, Functions, Standard A, Define, Evaluate, and Compare Functions. Our topic today continues to be from Mathematical Models, Defining Functions in Table Form. Our essential question is, how do we identify functions in table form? Please take a moment, pausing the video if you need to set up your header. Be sure to include today's date, set up your question column, and your note column, and resume the video when you're ready to begin. So for this week, we've been working with functions, and the definition being exactly one output, or y value, for each input, represented by our x values. And we've been trying to decide in different forms whether or not a relationship is a function. And today we're going to be doing that with tables. So let's go ahead and take a look at our first example. So here I have set up a table of values. Our x is representing our input values. Our y column is representing our output values. And from table form, what we want to do is map it out. And today all of my examples are going to be with numerical data, but this could be done with categorical data as well. But the process would be the same. The first thing you want to do is set up a map, a relationship map. So we set up our first oval representing our inputs, and we list the values from our table. And I've gone ahead and done this for both the inputs and the outputs. And then we want to start drawing arrows that matches each input with its given output from the table. So from the table we can see that -8 matches to 21. So we would draw an arrow from -8 in our input oval to 21 in our output oval. And we're going to continue to match up the values this way. -5 matches up to 14. -2 matches up to 7. And 1 matches up from 0. And we find all this from our table, matching each input to its output. So this seems to match our definition. There's exactly one output for every input. So 1-to-1 matchup. So we would say that this table is a function because there's only one output for each input. In other words, our map is helpful because we can see that there's only one arrow from each input value, and that helps us realize that this is a function. Let's take a look at the next example. So here's our next table. Again, we've listed numerical data, our x column representing the input values, and our y column representing the output values. Again, we're going to go ahead and set up a map. There's some interesting things happening that we see right away. This value -10 is being listed twice in our table. Although it's listed twice in our table, and I made a little side note about this, we're only going to list it once in our relationship map. So let's go ahead and set that up. So I have my two ovals. Here are my input values. I've copied them from the table, but I'm only using -10 once. And then I also copied down the y values in my output oval. And now we want to use those arrows again to match up each input value to the possible outcome value. Let's go ahead and do that now. So I've gone ahead and matched up each value as it corresponds to its output value in the table. -10 can match up to 16, but -10 also matches up to 14. 0 matches up to 5, 10 matches up to 9, and 20 matches up to 12. So this right here presents a bit of a problem. It's no longer predictable. If I put a -10 in, I don't know if I'm going to get 16 or I might get 14. Because it's not predictable, or because we can see two possible outputs for one input, this is not a function. So even though it works for 0, 10, and 20, this is not a function because the input value, -10, has two possible output values. The map again is helpful because we can see that there's at least one input value that has two arrows coming out of it. So let's take a look at our third and final example. Here's our list of input and output values in our X and Y table. What I'd like you to go ahead and do is set up your relationship map and draw in the arrows and try and decide for yourself, do you think this is a function or not a function? So as you set up your relationship map, it should start to look like this. And remember, here in our output, in our Y column, we see that there are two 48s. Even though there's two 48s in our table, we only want to list it once in our map. And then we want to use the arrows to match up each input value to its possible output values. So your map should start to look like mine. 30 matches up to 48, 24 matches to 36, 18 matches to 48, 12 to 15, and 6 to 10. So this is interesting in that we see 30 matches to 48 and 18 also matches to 48. But yet, in our map, we still see every input value has only one arrow matching up to an output value. So in fact, this is a function. There's one output value for each input value. If I get 30, I'm going to get 48. If I put in 24, I'm going to get 36. If I put in 18, I'm also going to get 48, but that's still predictable. There's no way that there's an input value that gives me two different output values. So we would say that this table is a function because there's only one output for each input. The map is helpful because we see there's only one arrow from each output value. This is going to conclude our video for today on defining functions in table form. Please take a moment to make sure that your notes are complete, and you may want to begin to write your summary and your study guide questions.